Hey guys, so yesterday we talked about graphing absolute value functions and we really focused on those two letters, H and K. Well, today we're not going to just focus on them, we're going to focus on the entire equation. So we're going to focus on A, B, H, and K. So first let's talk about how A and B affect my graph. Well, A and B really affect the slope of my graph. In other words, we call them a vertical stretch or a vertical compress or a horizontal stretch or a horizontal compress. They kind of have a very similar effect. We're going to talk about what causes that. So, like for example, if my number in front of my absolute value, which is my A, if my A in front of my absolute value is like a 4, it's going to be a vertical stretch by 4. You can kind of think of that as being your slope. Your slope would be 4. We'd go up 4 over 1, up 4 over 1. But we still have to create that V. So one of them would be a positive 4 slope. The other one would be a negative 4 slope. Okay? The same thing is true if I have like a fractional answer. That would be a compress, so my V would go down. And so it would be a vertical compress by 1/3. Once again, you can kind of think about that as your slope. Now the opposite is true for if you the number inside your absolute value. So if the number inside of it is 4, it is a whole number, just like your H, it's going to be backwards. So this one's going to be a horizontal compress by 1/4. See how it flips there, a horizontal compress by 1/4, and then this one, if it's a 1/3, it's going to be a horizontal stretch by 3. And so in both those cases, it's kind of backwards. But remember, you're going to have your notes on your homework, on your quiz, on your test. So you're going to be able to look back and say, okay, which one was that? What do I do? So make sure you definitely hang on to this page and talk about A and B. Once we try some, it's going to be pretty second nature as we go. But just some things to remember. Your H and K create what's called your vertex, right? And your vertex is that point where your graph intersects. And so H and K, and your H is always going to be the opposite of what it is in here, because since it's a minus H, we're going to change it to a plus H whenever we bring it out. We also need to talk about a maximum or a minimum, okay? If you have a graph like this, where it's going down, the point on top is a maximum. If you have a graph opening up like this, the point on bottom is a minimum. All right? And we just name that point. It's going to be my vertex. It's always going to be my vertex. So we just need to name my vertex as either a maximum or a minimum. Okay? So your max or minimum value is also going to be what your K is. So you're going to go K down or K up, and that's going to affect that. Okay, let's take a look at number 3. And we have a lot of stuff to answer here on number 3. So starting off, here's my equation. So think about your initial formula that we have, and that's going to be y equals a times the absolute value of b x minus h plus k. Now, I don't really have a b on this one, right? There's no number there in front of the x on the inside of my absolute value, so my b is just going to be 1. So we're not going to change with a horizontal stretch or horizontal compress. You know, I don't know why I'm wearing this mask. I'm just so used to wearing it at school. I'm going to take this off so you can hear me better. All right, so my b is going to be 1. My a out here in front is going to be -2. My h here is going to be 4. And my k out here is going to be 3. Notice it was a -4 here, but when I'm talking about what it actually is, we say it's a +4. Okay? All right, our parent function. Your parent function is always going to be the same as the starting point. Your parent function is always just going to be y equals the absolute value of x. Just like that. Okay? Now, my transformations. My transformations are going to be that I'm going to go first, but with my h being a +4, we're doing the opposite of what's in there. So remember that we're going to go to the right 4. Okay? Okay, so my transformations, we're going to go to the right 4. You know what? I'm going to write that in the correct color. Since that one is, we chose blue for that, we're going to change that. We're going to say to the right 4. And then since my k is 3, we're going to shift my graph up 3. Up 3. So that tells me where my vertex is. So my vertex is going to be 4, 3. So we can go over 4, up 3, and there is my vertex. Now we're also going to have 2 more transformations. And they're both going to come from this a value. First and foremost, that a value is negative. So we're going to have a negative transformation. So it's going to be a reflection. If we ever have a negative a, remember it's a vertical reflection. So we're going to have a vertical reflection, and we're going to have a vertical stretch by 2. Okay? So I'm going to write vertical stretch by 2. So we have a vertical reflection, and we're going to have a vertical stretch by 2. Okay, now my opening direction. My opening direction, since we have that vertical reflection, my opening direction has to be down. So now let's go ahead, let's graph this, okay? So if I'm going to graph this, I'm first going to find my vertex. Then my axis of symmetry is kind of what the next thing that we're going to find. My axis of symmetry is going to also be related to my h, and it's going to be, my axis of symmetry is going to be at x equals h, but in this case my h is 4. So I'm going to write a reminder. Your axis of symmetry is just whatever h is. Just like your vertex is h comma k, your axis of symmetry is just whatever h is. So I'm going to have an axis of symmetry right there, okay? So there's my new axis of symmetry. Now my normal graph would be opening like this, right? From that vertex. But we've done a lot of stuff to that normal graph. We have flipped it, so I've had a vertical reflection. So with that vertical reflection, it's going to be opening downwards, and it's going to have a vertical stretch. So it's opening downwards, but we're also stretching it vertical. We're making it skinnier. In other words, my slope is going to be -2. And so we're going to like go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. So it's going to look like this as we go down. So now I can draw what my graph looks like. And once again, it does not have to be perfect. It does not have to be exact, but we're able to draw what my graph looks like, and that's helpful. Okay? Now let's talk about max or min. My maximum, well, first off, is this a maximum or a minimum? Yeah, it's going to be a maximum. I'm going to have a maximum point there. Okay? As my graph goes, we have a maximum point. And my maximum point is just going to be the same as my vertex. It's going to be at 4, 3. So there is my maximum point. My domain is going to be, well, let's see. Remember, domain is my left to right. Is it going to go everywhere to the left? Yes, that arrow is going to keep going to the left. Is it going to go everywhere to the right? Yes, it's going to keep going all the way to the right. So my domain is going to be all real numbers, -infinity to +infinity. My range, though, I have a maximum. I have a maximum number that my range can hit, and that's what we talk about when we say the range. So it's going to start from -infinity, but it's going to hit at that point, and my maximum is going to be at 3. That's the highest point. So we're going to say y is less than or equal to 3, or we can write it as negative infinity to 3 with the brackets like that, because it's everything up to that point. And last but not least, I know this is a ton of information that we've covered on this first problem, but the last but not least, our y-intercept. My y-intercept is going to be whenever x is 0. Okay, so we're going to take real quick my original equation, and I'm going to plug in 0 for x to find what my y-intercept is. So I'm going to go y equals negative 2 times the absolute value of 0 minus 4 plus 3. Then we can just do some work. 0 minus 4 is negative 4. The absolute value of negative 4 is positive 4. So now we're going to go negative 2 times 4 is negative 8. And negative 8 plus 3 is going to be negative 5. Oh, hey, that makes sense. There is my y-intercept right there. So my y-intercept is going to be at 0, negative 5. All right? Hopefully that all makes sense as we're looking at that graph. All right, but now let's talk about some transformations and get some practice with that. So let's turn the page and let's state the transformations on this parent function. This first one's easy. We only have one number, and it is my k. And my k controls my up and down, right? So if it's minus 3, the only thing we're going to do here is go down 3. Let's take a look at this one. Well, I have a negative in front, we have a minus 5, and we have a plus 2. So that plus 2 is pretty easy. That means we're going to go up 2, right? Because that's my k. Now my h here, remember, it's backwards, and so that controls my left and right. And so what I'm going to do here is I'm going to go right 5. Then, lastly, my negative out in front, we have a negative a. And so it's just still 1, but it's just negative, so we're going to have a vertical reflection. Awesome. Now, this one, we have that 2 out in front, so my a is 2, so we're going to have a vertical stretch by 2, and then we're also going to have a 1 here as my h, but remember, it's always a liar. It's hanging out with its x, it's lying to somebody, so we're going to make that h, we're going to make that a negative, so we're going to go to the left 1. Okay, last one. This one's kind of tricky because we have a b. You're not going to see a whole lot of b's, they're kind of weird, but that b on the inside there is going to affect my graph. So first off, with this b in here, the first thing it's going to do is it has a negative, so we're going to have, instead of a vertical reflection, we're going to have a horizontal reflection. And since it's a fraction, remember, it's backwards. So instead of being a compressed like it would normally be, this one's going to be a horizontal stretch by 2. Okay, then I have this 3 out in front. Remember, that's my a. So that's going to be a vertical stretch. So we're just getting all the stretching in. It's like we're in yoga or something. By 3. And then my negative 5 there at the end is my k. And so we're just going to go down 5. So there was a lot to that. But remember, look back at your notes, okay? So if you're ever asked, like, is it a stretch, is it a compress, whatever, look back at your notes and compare it to those fractions that you have there, okay? All right, let's take a look here at 8, 9, 10, 11, 12. We might skip some of these as we go through, but let's see here. So for 8, we have a vertical reflection and a horizontal stretch by 4 and up 3. And we're going to write the function for this. So a vertical reflection, that means I'm going to have a negative a. So let's start off with that. We're going to go y equals a negative a. Oh, then a horizontal stretch by 4. So remember, since it's on the inside, since it's my b, it's going to be backwards. So this is going to be 1/4 on the inside of my absolute value. And then we're going to go up 3 on the end. Hey, that's pretty easy. Just plus 3. Next one, right 6. Ooh, right 6. So that means my h is 6. But remember, when I plug it in, it's going to be backwards. So we're going to do a minus 6, x minus 6 on the inside of my absolute value. And we have a vertical stretch by a factor of 2. So we're going to have 2 on the outside there. Okay? Let's get here to number 11. So number 11, we have a vertex of 6, negative 9. So whenever we have a vertex of 6, negative 9, remember that's my h, that's my k. And we're going to flip that h, so it's going to be a minus 6 on the inside. So we're going to have y equals the absolute value of x minus 6 and a minus 9 there on the end. Number 12, we have a equals 3, h equals negative 5, and k equals negative 7. So this is easy. All we're going to do is plug these in. So we're going to go a at the first. We have no b. So a minus 5 for my h. When we plug it in, it's a liar, so we're going to flip it. And then k is equal to a negative 7. We're just going to throw that in on the end. Okay, what about if I wanted to change things up? If I wanted to shift this down 4 and left 5, what would be the new equation? Well, if I'm going to go down 4, we're going to take that 8. We were up 8. Now we're going to go down 4. So instead of that being an 8 anymore, it's going to be a 4. And then to the left 5, that means that we're going to have a plus 5 on the inside because it's backwards. So I would add 5 here. And if I go negative 4 plus 5, that's just going to be a plus 1. So it's all a little backwards, but this does help us out. We're just going to go y equals 3 times the absolute value of x plus 1. Close that off, and plus 4. Okay? And then lastly, write a function g whose graph is a vertical reflection of this graph. Well, to do a vertical reflection, I just need to have a negative a, right? So we're just going to go f. Instead of saying f of x, though, it wants us to name our graph something different. It wants us to name our graph g. So I'm going to name it g of x. Remember, g of x, f of x, the same thing as y. It's just a name for our graph. We're going to go g of x equals negative. That is the ugliest negative in the world. Let's try that again. Negative absolute value of x plus 3 plus 1. Okay? Negative x plus 3 plus 1. All right, guys. Well, that is our transformations. We're